Good morning, class. Today we are going to review our engine four-stroke principle, and we're going to need to do that in order to move on to the next part of our four-stroke principle. So first we're going to just review real quick. We have four strokes. We have the intake, the compression, the power, and the exhaust. Real quick, the intake is the piston is coming down. It's going to suck in fresh air. If it's a diesel, it just sucks in fresh air. If it's a gas, it'll suck in some air-fuel mixture. Unless it's direct injected, then it will only suck in air because the direct injected gasoline engine will operate similar to a diesel engine. So we'll just act like this is a diesel, and we're going to suck in some fresh air on the downstroke. The upstroke compresses the air and makes it nice and hot. Then we inject the fuel into the hot air, and it begins combustion, and it makes a little explosion right there, forces the piston down, and that's what causes our crankshaft to spin. And that burnt fuel then is exhausted on the upstroke, on the exhaust stroke, and that's forced out through the exhaust valve. Now remember, we have our valves that are open and closed at certain times for these strokes to operate properly. And so what we're going to talk about today is our cam and crank relationship to these valves up here. So on my intake valve, I have to have the intake valve open on the intake stroke. And so, and that's when the piston comes down. But on the power stroke, when the piston's coming down as well, I have to have both of those valves closed. So what we're going to talk about is cam and crank relationship. So right here we have the camshaft sprocket and we have the crank sprocket. The crank sprocket is half of the size of the camshaft sprocket. And the reason that is because we have to make sure our valve timing is correct for our four-stroke principle right here. And what has to happen is on our intake stroke, our intake valve, this blue valve here is the cooler valve of the two, is going to be open. Now, if I had this crank pulley and cam pulley the same size, every time the piston would be going down, every time that piston would be going down, the intake valve would be open every single time. So I have to be able to skip a turn from my intake stroke and my power stroke. So the intake valve will only open every other downstroke. So the way they do that is they make the crankshaft pulley and the camshaft pulley different sizes, and you can look at it either way. The crank is half the size of the cam, or the cam is twice the size of the crank. Either way works. This is a timing chain setup, so this is going to be how a overhead valve engine would look. So this is the four-stroke overhead valve. This could be gas or diesel, and so this is how they set that up, and I'm going to try to get some demos for you guys to see on that. On a diesel engine, we're going to look at this one here, and this one is set up to where it's gears. And so this is the big Volvo engine that we have out there, and we have a cam gear that's on the very top because it's an overhead cam engine. This is a diesel, and the injector pump has a gear as well, and it is the same size as the cam because the injector pump is only going to inject fuel on one part of the four-stroke principle, which is the compression stroke. So that has to happen at the same time that the valves are opening and closing at the timing, so that it doesn't happen any other time, because if we inject it on our exhaust stroke, then we have an issue. So we have to make sure we only inject it at the same time that we're going to get the valves open. And so on the crankshaft, again, this is half the size. And